All right. Last section of this chapter. Continuity. Continuity. I don't know if that's spelled right. Continuity. All right. If we were to graph an equation, and let's say this equation went like this. In other words, we graphed what? This would be a negative x cubed. Negative x cubed. That'd be a graph of negative x cubed. It's continuous all the way through, and if you notice here, there's no break in the graph. All right, it continues all the way through. It goes on for infinity both ways, but it doesn't ever break in the graph. This is called continuous. Continuous. It's a continuous motion. There's no break in what's happening. I just put that back on a little bit ago. All right. If we were to graph something that, let's say, came down like this, and then there was a hole in there, in other words, it didn't continue through, this would be discontinuous. This is called point discontinuous. Point discontinuous. All right. There's a difference between the two graphs. And it is not continuous. Let's say that point was 2. At 2 it would not work. All right. Where would that be? What kind of equation would you think that would be? What if we had an equation like this? All right. That might be an example of an equation where at negative 2, it's undefined. But yet, everywhere else it would be. Okay, I'm not even sure this would what that would look like. I kind of guessed at what that would be. But that might be an equation where at 2 it's undefined, so we can't have a point there. All right? Those are continuous and discontinuous graphs. Now, there's different types of discontinuous. There might be a graph like this, and it would look like this, which would mean this is infinite discontinuous. All right, infinite discontinuous. That's one of the discontinuous graphs you could have. We already did one where we talked about a point. Because they're never going to reach each other. They're never going to be continuous, let's say, at the y-axis. And essentially your x-axis too. All right. We're looking more at the y-axis. It's really not, it's going to be infinite discontinuous at that y-axis. This is called point discontinuous. And the last one would be like this. We have a graph coming down here. We'd have a solid point, and then down here we'd have an open point, and a graph maybe would go this way. And this is called jump discontinuous. All right, that's jump discontinuous. This is point. So we have infinite, point, and jump discontinuity. All right. All right, let's take a look at an example. Let's see. That's not what I want to get into. All right. Let's take a look at an equation here and figure out what discontinuous, if it's discontinuous at what. If we had x squared minus 4 over x plus 2. If we were going to graph this one, where would it be discontinuous, Michael? Where do you think that would be discontinuous? Where would it not be, where would it be undefined at? -2. Right? Because if x is -2 equals -2, then we'd have 0 in the denominator, right? So we couldn't have that. But I want you to look at this. If I was going to break down this equation, I could make this x minus 2 and x plus 2. I FOILed out x squared minus 4. Now this is divided by x plus 2. What could I do with my x plus 2's? Cross them out. So I'd really be graphing x minus 2. That's what I'm going to graph. If x equals 1, then my y equals -1. If it equals 0, it equals -2. If my x equals 2, my y equals 0. I can graph this. I could even put a -2 in for this, but the problem is this has to be undefined here per this equation. That's what we're actually graphing. So if I was going to graph this, I could put, let's see, if my x is 0, I'd be down 2. If my y is 0, I'd be over 2. So I'd essentially be coming, let me make my graph going this way. Let's go back to 1, 2. We'd get to this point, we'd put an open circle. Because at -2, when x equals -2, it's undefined. Right here, right? We figured that out up here. And if, because we're really graphing the original equation. Oh, my graph looks pretty good. Yeah, but we're actually graphing this equation right here, Kaylee. All we did is we reduced this down, but this is the equation you'd graph. So to try and graph this equation would be tough. We can break it down and we can make it real easy by looking at this, just this portion of it. But when you graph this equation, we cannot have x equaling -2. All right? Because at -2, then it's undefined. All right, so that's why it'd be an open circle right there. And this is called what kind of discontinuity? What is it? What kind? There's point. There's point, jump, and infinite. All right? This is what you're going to be doing on your assignment. Your assignment is going to be being able to graph this, being able to figure out what would it look like? Well, then, if it did, maybe your line wouldn't be here. It would actually start up here with a solid point. I don't know. You have to figure it out. That would help. I hate it when that happens. Oh, that's, you know what I'm doing? I'm looking to see if anybody's sitting at my desk right now. Oh, don't scare us. All right. Okay? That was recorded, by the way. All right. You guys have any questions of what you have to do? The key to this is going to be you look at the original equation, find out how you can break it down and make it easier, but you have to find out where this is undefined. If you can find where it's undefined, then you're going to be okay. We'll just cut that one out. All right? Let's do for the assignment. Let's do, and you got to tell me, is it continuous or not? What if it's discontinuous? Then what kind of discontinuous? I want you to do page 170. Page 170. I want you to do. Let's see. I did that one already. So let's do 14, 16, 21, 22, and 23. 14, 16, 21, 22, and 23. Page 170. 14, was it 14, 16? 14, 21, 22, and 23. That gives you all 5 problems to do.